Today we're going to talk about solving quadratics by factoring. Our first step before that happens is using this zero products property, which you guys saw on Monday. Quick review: when you've got two binomials that equal to 0, that means one of them has to be equal to 0. So I'm just going to split this apart into two different equations. Both equations are going to be set equal to 0. And then I want to solve for x. So my two solutions, which is what I'm trying to find the roots, where they cross the x-axis, is x is equal to 9 and x is equal to negative 2.5. Why don't you go ahead and try A and B? Your two answers should end up being x is equal to 5/3 for one solution, and your other solution is negative 11/4. On B, your solutions are roots. Again, those x-intercepts should be x equals negative 1/2 and x equals 2. That's what we did on Monday. Now we're going to take it one step further. Taking a look, we've got this quadratic. Here's A, here's B, here's C, and notice that it's equal to 0. We can't factor unless it is equal to 0. So I want to go ahead and I want to factor this. To factor this, I'm going to set up my ACB table. A times C in this problem is 20. If you need to put that 1 there, put that 1 there. B is 9. So what two numbers multiply to 20 but add to 9? That's going to be 5 and 4. I'm going to go ahead and factor this by grouping. If you factor by using the box method, that's fine. Go ahead and do it that way. I'm going to go ahead and put that equal to 20. Split it up into my two sets of parentheses. My GCF of the first one, they both have an x in common. So my GCF is going to be 1x. And if I divide both of these terms by x, I get x plus 5 left over. I'm going to look for the GCF here as well. 4x and 20. They have a positive 4 for GCF. Notice I can't take x out because the 20 doesn't have an x. If I divide by 4 to both terms, I end up with x plus 5, and that's still going to be equal to 20. Notice my two sets of parentheses match up perfect. That's what I want. So I'm going to come over here and write x plus 5. Again, that's coming from that purple. And then I'm going to take my two GCFs, which was 1x and 4. And that's going to be my other set of parentheses. And that's still equal to 0. From here now, I'm going to use that zero product property. So I'm going to split this up. I'm going to do x plus 5 has to be equal to 0, or x plus 4 has to be equal to 0. And I want to get x by itself. My two solutions, or roots, or x-intercepts, would be x equals negative 5 and x equals negative 4. Why don't you pause and try A on your own on the next page. On A, when you factor, you should be ending up with this. So when I solve that, then to get x by itself, I'm just going to have one solution, one x-intercept, because my parentheses are the same, and that solution is x equals negative 8. Now I want to look at one other example. I want to take a look at B. Notice B, we're not equal to 0 right now. I can't factor this unless it's equal to 0, so I need to move that 64 over to the other side. So to do that, I'm going to subtract 64 here and subtract 64 on this side. So my new equation looks like x squared minus 12x minus 64 is equal to 0. Now that it's set equal to 0, I can go through and I can factor. Here's A, here's B, here's C. So I'm looking for two numbers that multiply to negative 64 and add to negative 12. That's going to be negative 16 and 4. So if I go ahead and set this up to factor, I give you a chance to go ahead and write that down. Get my two sets of parentheses. Factor out the GCFs from each set. I have matching parentheses again, which is what I want. So I'm going to go ahead and take, take my GCFs and write that first. So again, that's where that's coming from. And then I'm going to take what's in green. But because we have an equation, I need to go ahead and solve that using the zero products property. So I'm going to split this up and do x plus 4 equals 0 and x minus 16 equals 0 to solve for x. Two and 3, I would just look at the key and see what that math looks like. Your answer for 1, your solution should be -1 and -4. For 4, once you change this to get everything over to one side, so that way it's equal to 0, you should end up with solutions or roots or x-intercepts of -1 and 7. 5 is already set equal to 0, so you can go ahead and factor that. And our solution should end up being -5/4 or -1.25. And x equals -1. 6, we need to move that 5 over. So we have it set equal to 0. We can't factor until it's set equal to 0. And once we do that, we would end up with x equals -2/3 for one x-intercept and x equals 6.